Hi, in this video, we will continue to talk about R programming. There are some important components in R coding: condition and control flow, loops, self-defined functions, and the apply family of functions. In this video, we will talk about conditional flow. The basic conditional construction in R is the if-else statements. The syntax is if parenthesis condition action 1, else action 2. Condition is a conditional expression, and it must evaluate to a single logical value. So this condition can only yield one single logical value, true or false, or T or F. And if the condition is true, action 1 is executed. Otherwise, action 2 is executed. In the case that the program does nothing if the condition is false, there is no need to include an else statement. In that case, the syntax is simplified in this way: if condition action. Let's see one simple example. X is equal to -5, and if x is greater than or equal to 0, y is equal to x, else y is equal to -x. So apparently y is equal to the absolute value of x. Since x is equal to -5, the condition is false. So action 2 is executed. Y is equal to -x. -5 is 5. So y is equal to 5. Sometimes we may have two or more conditions in the condition part. In this case, we should use the double AND or double bar, double OR to combine these two conditions. That's because, the condition can only yield one single logical value, and double AND and double bar will also yield a single logical value. And A and B means both A and B. So this will only be true if A and B are both true. And double bar means or, A or B. A or B is true if at least one of A and B is true. Okay, so let's see some examples. X is 5, Y is 3. If X is greater than 0 and Y is less than 0, Z is equal to X plus Y, else Z is equal to X minus Y. So in this conditional flow, we create a new variable z, which is based on the values of x and y. So apparently x is greater than 0 will yield a true, and y is less than 0 will yield a false. True and false will yield a false. So action 2 will be executed. Z is equal to x minus y. 5 minus 3 is equal to 2. Then take a look at the second example. Or, the first condition yields true, the second condition yields false. True or false will yield true. So W should be equal to x plus y, which is equal to 5 plus 3, which is 8. So the point is, if we have two conditions in an if-else statement, then we should use double AND or double OR to connect them. Sometimes the actions have multiple lines or compound statements. In this case, we should use curly brackets to wrap them together to indicate that these few lines belong to one action. For example, if x is greater than or equal to 0, then y is equal to x and z is equal to -x. Else, y is equal to -x and z is equal to x. So in each case, we define two variables based on the value of x. Apparently, y should be equal to the absolute value of x, and z is the opposite of the absolute value of x, which is negative absolute value of x. So see, x equal to 5, which is positive. So action 1 is executed. Action 1 contains two parts. Y is equal to x, z is equal to -x. So y is 5, z is -5. Okay. The point here is if we have compound statements in one action, we should use curly brackets to wrap them together. And notice that I added some indentations. R does not insert indentations automatically. You have to do so by yourself. And I highly recommend you to insert indentation in your code because it will make everything very clear. Sometimes there are more than 2 possible choices. Notice that if there is only one if and else statement, then there are only 2 cases, 2 actions are possible. If there are more choices, then we need multiple if-else statements. For example, if we want to convert score grades into letter grades, then we should use this if-else flow. So we will follow the convention. If x is greater than or equal to 90, then the grade is A. Else, if x is greater than or equal to 80, grade is equal to B. So notice that else means x is less than 90. So this condition is false. And then at the same time, x is greater than or equal to 80. So in other words, if x is in between 80 and 90, the grade should be B, which is true, right? And then similarly, if x is between 70 and 80, the letter grade should be C. And if the score is between 60 and 70, the letter grade should be D. And the last statement is just an else statement. When the score is less than 60, then the grade is F. Okay, there is no if anymore. So the last else statement collects all of the cases that are not covered in the above conditions. So since x is equal to 85, which is in between 80 and 90, so the grade should be B. Lastly, let's take a look at a very special function, the if-else function. So this is a vectorized version of the if-else structure. So the basic syntax is if-else condition A, B. If the condition is true, the whole function will yield A. Otherwise, it will yield B. For example, x is equal to -5. And if x is greater than or equal to 0, return x. Otherwise, return -x. So in other words, the variable y is equal to the absolute value of x. Okay, since x is equal to -5, y is equal to 5. So this is a single value case. And this function is a vectorized version of if-else because it can handle vectors of conditions. So the condition can be a vector. So the condition can yield a vector of true or false values. In this case, the function returns a vector of the same length as condition with elements ai if condition I is true, otherwise bi. Okay, so let's see this example first. X is a series of consecutive integers from -5 to 5, so totally 11 numbers including 0. And if x is greater than 0, x, otherwise -x. So notice that x is greater than 0 will yield a vector of true or false values, 11 of them. Okay? And similarly, x is a vector of 11 values. -x is a vector of 11 values. So the function if-else will deal with the condition element-wise. For example, the first value is -5. And for -5, the condition is false. So the first element of y should be -x1, which is 5. Okay? Second value is -4. The condition is still false. So negative and -4 will be 4. Okay? Consequently, the result will be like this. For all of those negative values, the opposite will be returned. Okay? And 0, okay, same thing. And positive values, the value itself will be returned. The point here is that the condition is a vector, and also the options are also vectors. If there are 2 or more conditions, then what should we do? We should use element-wise logical operators to combine those conditions together. For example, we generate 1,000 observations from the standard normal distribution using the rnorm function. And we know that for standard normal distributions, 99.7% of observations should be in between -3 and 3. So in other words, if a standard normal random value is greater than 3 or smaller than -3, that value is kind of abnormal. We will use this if-else function to identify those abnormal values. Okay, so the condition is x is greater than or equal to -3 and x is less than or equal to 3. So if you combine these two conditions together, it is x is less than or equal to 3 and greater than or equal to -3. So this is the normal range. Consequently, if a value is in this interval, then normal, right? Otherwise, abnormal. So the point is that both of these two conditions yield a vector of true or false values, and we can only use element-wise logical operators to combine these kind of vectors of logical values. Okay? And also notice that the results are single values, normal or abnormal. Is completely fine, because if the dimensions are different, then we will recycle a and b in the function. So let's see the result of the simulation. Y is equal to this. So y is a character vector which contains either normal or abnormal. Okay. Let's use the table function to summarize the result, the distribution of y. It turns out that exactly 3 out of 1,000 values are abnormal and 997 are normal. So because this is a simulation, so it is really consistent with the theory of normal distribution. Similarly, if the condition is something like A or B in the if-else function, then we should use double bar instead of single bar, because double bar can handle vectors of logical values. Alright, that's all for this video. In the next video, we will talk about loops, for loops, while loops, and a special type of loop, repeat. And thanks for watching. See you next time.